Hi everyone and welcome to your first masterclass for your first geography exam happening this afternoon. Now the way this is going to work, obviously I would love to be with you in the classroom going through this in person, but unfortunately I'm not. So the way this is going to work, hopefully, I will go through a few basics that we just need to remember for the actual exam, and I'm then going to go through, this is really important, I'm going to go through potential questions that will be in your exam this afternoon. Right, so for now, pens down, don't have anything in your hands, listen to what I'm saying, pay attention, here we go. Right, this exam is made of three sections, A, B and C. Section A, answer everything, Section B, answer everything. But in Section B, there will be questions focusing on cold environments and hot. We answer questions, of course, on cold environments because we studied Svalbard. In Section C, you answer all questions on coasts and all questions on rivers, but you do not do the last section on glaciation. So nothing on glaciation. What this means is you'll be writing, and then some of you will panic thinking, oh my God, I've got like 10 pages still to go. No, you haven't. Because those last 6, 7, 8, 10 pages will be on the last section. So don't panic if you've got loads of pages left at the end of the exam booklet. You will have, because you don't answer those ones. So Section C, coast and rivers only. A few things to remember. This was a weakness of this particular class back in December. You're all absolutely outstanding at it now. But any question where there is a figure, figure 2 shows this, so explains something, make sure you refer to the figure, the first thing that you do. So the first thing that your pen writes when it touches paper is figure 2 shows, and do that. Get that bit done first, and then talk about your own knowledge. And lastly, your 9-mark questions, normally 3 paragraphs and end with a conclusion. Most of those paragraphs, especially the first 2, think of the scale, the weighing of the different options, talk about that, and most paragraphs will start with a sentence to some extent. Right, quick overview of your case studies. So for tectonic hazards, you've got Nepal and Chile. Nepal, 9,000 killed, Chile, 500 people killed. You've got your atmospheric UK weather. So for the UK's weather, if you get a question on that, talk about the beast from the east. This was the really cold weather we had in 2018 when everything was covered in snow. Beast from the east. And your tropical storm is Typhoon Haiyan, where 6,300 people were killed by that storm in the Philippines. Climate change, for adaptation, talk about the Maldives Islands that are becoming flooded due to rising sea levels. What are they doing to overcome that problem? Living world rainforest, Malaysia, and your cold environment, I've already mentioned this, is Svalbard. Coasts, defences, talk about Eastbourne, and rivers flooding, talk about the Somerset River floods. Now, when it comes to your tectonic hazards, we know Nepal, we know that there was 9,000 people killed, 8 million people affected, hospitals, homes, bridges, railways destroyed, devastation. We also know our HIC earthquake case study in Chile, 500 people killed, 800,000 people affected, and all the same things, hospital, roads, bridges destroyed, also a tsunami. But what I think will come up in the exam is not particularly the case study in Nepal or Chile, but what is it that makes some earthquakes, some particular hazards worse than others? Because this hasn't come up, okay? So pay attention now. So, why is prediction, planning and response worse in developing countries, so LICs? Okay, here we go. So sometimes these locations are risky locations. Think about Nepal. Most of Nepal is very mountainous, and that's what slowed down the relief efforts, hence making it worse in the long term, because people couldn't be rescued quick enough. These countries, LICs, they cannot afford safe, well-built houses. The same is also true not maybe for tectonics, but also for atmospheric. Look at Typhoon Haiyan. Most of their homes were built along the coastline, weren't they? Because they're all fishermen and working in the fishing industry, the primary job sector, but those homes were not well built because they're a poor country. They cannot afford their building materials. The governments do not have money to provide aid, which slows it down, which is why they've got to ask for money from HICs. Communications are poor, warning, evacuation may not happen, and there could be a lack of education. People don't know what to do. When there's a big hazard, tectonic or atmospheric, they don't know what to do. So, if there's a question on why are things worse, why are impacts greater in LICs, this is why. Okay? Right, cause of a tropical storm has never come up. Let's go through this bit by bit. So firstly, warm, moist air. Right, we then look at Typhoon Haiyan in the Philippines. Now, I'm not going to go through all the impacts because you know all that. 6,300 people killed, bridges destroyed, roads destroyed, schools destroyed, people displaced, you know all that. That's easy. But what's not come up in the exams, previous exams, is the responses to tropical storms. Now, with a response, remember, a response is what you do after the actual event. The planning, prediction before, the response is afterwards. Now, there's two types of response. There's an immediate response, this is what you do straight away, and then there's a long-term response. So this could go on for many, many years after the actual event. So here we go. The immediate responses to Typhoon Haiyan in the Philippines are: the government provided food, water, blankets, tents. They asked for financial aid from HICs because they're an LIC. They need extra money. The army was sent in, the armed forces were sent in to evacuate people from flooded areas. And field hospitals were set up to take the strain off the healthcare service. The long-term responses, everything was rebuilt. Roads were rebuilt, bridges were rebuilt, airports were rebuilt, ports rebuilt, homes were rebuilt. This could take 10 years. Both of which, very important, because both help people in the short term and the long term. Now, I mentioned this already. If you get any questions on the UK extreme weather, this is what you talk about. We've got two examples here. So you've got the Beast from the East in 2018. Do you remember that, when we had really, really heavy snow? Like schools were closed, the roads were out of action. So the Beast from the East, cold weather, very extreme. And do you remember a few years ago when we had the big tent on the field because of the really hot weather to keep people out of the sun? In 2022, we had 40 degrees temperature. So real extreme, really cold, really hot. If you get a question on UK weather, use these as your examples, okay? Things closed down, roads were closed, people didn't go to work, sometimes the schools were closed. So it disrupted the day-to-day life in the UK from these two examples. Right, the teacher in the room, could you now pause the video? I want all the pupils to write 1 to 10 in the margin. Do that very quickly. Once 1 to 10 in the margin is written in, press play, and there's going to be 10 questions coming onto the screen. All pupils, you've got a few seconds, very quick, to answer each question. You're only going to have to write one word per answer. So think quick, write quick. Once we've got the 10 answers on your page, I'll then go through the answers with you, and then it'll be back to me. So pause the video now, please. back. So hopefully you did all right on those questions. And if you didn't, don't worry, it's all good. Right, so evidence of climate change. So if you get a question on what's the physical evidence that we can visually see out there in the world which indicates the climate is changing, so either the temperature is rising or falling, this is what you would say. So firstly, we can visually see shrinking glaciers, those big rivers of ice in mountain ranges, and there's melting ice in the south and then the north and southern hemisphere. So that's melting, indicates the temperature is increasing. We also have rising sea levels. This is evidence in low-lying coastal areas. For example, the Maldives Islands, I'll talk about that in a minute, or maybe Bangladesh, very low-lying, lots of coastal flooding. Also, especially in northern Africa, in the Sahel region, we have drought and desertification. What about natural causes? I've not had a question on this in a long time. So a natural way, a natural event that causes the climate of planet Earth to change. So no human involvement, the natural events. There's 4. You've got a volcanic eruption, sunspot, asteroid, orbital. Let's go through these one by one very quickly. Volcanic eruption. Huge eruption. All of that ash gets emitted into the atmosphere. That ash is thick. It blows around in the atmosphere. Now that ash, my arm, blocks out the sun's rays, so the sun can't get through. Therefore, of course, the temperature will reduce. Second one, sunspot theory. Scientists say that when the sun has these like dark spots all over its surface, it indicates that the sun is giving out more energy and more heat. Therefore, the Earth's temperature increases. Asteroid collisions, same principle as a volcanic eruption. So asteroid comes in, all the ash goes into the atmosphere, blocks out the sun. This is what potentially killed the dinosaurs in the last great extinction. And the orbital theory, where the Earth's orbit changes from more of a rugby ball shape, elliptical shape, to more of a circular shape, football shape. And this changes the distance the Earth is away from the sun, therefore increasing, decreasing the temperature. Natural causes, no human involvement. When managing climate change, there's 2 categories. You've got mitigation, this, and you've got adaptation, what the Maldives are doing. So this is the mitigation management strategies. So this is all about reducing CO2 emissions. So using alternative energy sources, so solar panels or wind turbines. Because if we use more solar and wind, what are we not burning? Yeah, that's right, fossil fuels such as coal. Carbon capture, where we take out the carbon from the atmosphere and we pump it deep underground and we store it in the underground rock. Reduces CO2 emissions. Afforestation, the planting of trees. As we plant trees, we create carbon sinks. And a carbon sink, just like the sink in your bathroom where the water goes down the plug hole, the carbon sink is when the trees take out the carbon from the atmosphere, like a sink would take out water. A carbon sink from afforestation. And we also have international agreements. So this is when all the large developed countries, the industrialising countries, one with loads of factories emitting carbon dioxide all the time, when all these countries get together and they agree on targets to reduce their CO2 emissions. Now this is the adaptation, all right? So the first one was mitigation, about reducing CO2 emissions in the future. Adaptation is how do countries today that are being impacted by climate change, how do they overcome that problem? So for example, in the Maldives Islands, which are being flooded because they're low-lying, they are doing the following things. They are building sea walls along the coastline to prevent the rising waters from coming in. They are reclaiming land from the Indian Ocean by building new islands. Very clever. So people that need to be evacuated from flooded areas can go and live on the new islands. They're also evacuating people in an attempt to move them to Australia. And of course, they're also, and we've done this quite well, quite a bit in class, they're building homes on stilts. So when the floodwaters do come in, the floodwaters will go underneath their actual home. Right, let's look at deforestation. So you should know this, okay? This is quite simple now. The causes. Why is there deforestation in the rainforest? For example, Malaysia. So we know in Malaysia they are growing palm oil, or oil palm as it's sometimes called. Big export in Malaysia, makes them a lot of money. But there's also in all parts of the world, they're cutting down the rainforest to build roads, to connect places. They're building cities, urbanisation, the growth of cities. They have got more commercial agriculture, so large-scale farming, where they're growing crops to make money. Also activities like mining and HEP, hydroelectric power, the building of large-scale dams. So we know that these are the causes, but what about the impacts? So here we've got the environmental impacts of deforestation. Very simple. If trees are cut down, it's going to cause rivers to flood. Why? Because there's less trees, less interception. Less interception, less infiltration. Less infiltration, faster surface runoff. We also have soil erosion, because if there's fast surface runoff where the water's rushing off the surface really quickly, that soil is going to be picked up and washed away with it. It's eroding away the soil. Not good. And of course, our animals, the loss of animal habitats. So 3 major environmental impacts: river flooding, soil erosion and animal habitats. You can also say there's more CO2 in the atmosphere as well. Right, economic. So this hasn't come up. Environmental might come up, but economic's not come up for a long time. Now, an economic impact could be positive or negative when it comes to deforestation. So the positive economic impacts of deforestation would be: there's more land for farming, for mining, for generating energy. Now, all of these activities are good because they generate jobs for people. Now, you all know what to write here, don't you? Because if more people got jobs, that means they can pay more tax to the government's got more money to invest in, what is it? Education, healthcare, infrastructure. The area, the country, the region develops economically. That's a really good thing. Products such as oil palm in Malaysia are sold, they're exported to other countries around the world to make Malaysia money. And of course we can get minerals from the ground through things like mining, such as gold, and that makes money as well. But you've also got economic losses from deforestation. It's a bit of a balance here. So plants that could bring medical benefits and profits may become extinct. That would be a real shame. So that's social as well, of course, because it's to do with people. And of course, if we cut down the trees, the number of tourists going to the rainforests, who, by the way, spend a lot of money, which is amazing, their numbers might decrease. Because if the rainforest is gone, what are they going there to see? But this is where my money is at. So I think in the exam later on, you may get a question on how the rainforest can be protected. How can it be managed? How can it be conserved? 4 ways. Number 1, selective logging and replanting. What does that mean? That means when we go into a rainforest, we are very selective with what trees that we take from the rainforest. We don't just go in, like we used to, and clear the whole lot. No, that's not sustainable. We just select the trees that we want, that have grown to maturity, and we take those trees only. Replanting. Take it, replant it. Take it, replant it. Makes sense. Conservation and education. This is about a government educating their population on how to conserve and protect the rainforest. Because without the education part, people will not understand the value of the rainforest ecosystem. So you have to educate people on the importance of it, and they're more likely to protect it and conserve it. Ecotourism. So attracting people to go and visit the rainforest to make money. But this is good for social, economic and environmental. Socially and economically, local people can get jobs. That's amazing, right? So those are jobs in the tertiary job sector. That's a lot of money the government's going to get in tax. Also, the environmental impact of ecotourism it's minimal. The lodges, the tourist lodges that tourists will stay in will be made out of locally sourced material. So it blends into the natural environment. We also have international agreements. So this is where countries are working together in an attempt to protect the rainforest. A part of this could also be debt relief, where HICs will say to LICs, look, don't worry about paying us back. I know you're in debt to us, but don't pay us back. Spend that money instead on protecting your rainforest. Because the problem is, if LICs got to pay HICs back a lot of money, what happens is they spend it on things like mining and commercial agriculture. And therefore, they're cutting down the rainforest in an attempt to make money. Okay, welcome back. Hopefully you did right in those questions. We're now going to move into cold environments. We're almost there. Stick with me. I know your attention's probably dwindling in a little bit, but just stick with me. So, cold environment, your case study is Svalbard. Now, you know this off by heart. You should do. So, in Svalbard, there's 4 ways of making money. You've got mineral extraction, energy development, fishing in a barren sea, and tourism. All of which increase income, local population pay more tax to the government, government's got more money to invest in education, healthcare, infrastructure. Easy, we know it. But those opportunities are made worse by these particular challenges. So you've got extreme temperature. In Svalbard, it's minus 25 degrees Celsius. That makes it very hard to construct anything. Construct what? Houses, roads, bridges, ports, airports. And if you can't construct those things that are needed for economic development, you're not going to get any investment from TNCs, right? That slows down the development of the country. And there's also a lack of services, water, electricity. And don't forget, this is a hard place to get to. So they're trying to make money from tourism, but it's very inaccessible. It's not easy to get to. And then you've got all the problems caused by tourism. So for example, we've got oil leaks. Not just from tourism, this is like economic development. So this is happening in Svalbard, this is happening in Alaska, where we're extracting lots of oil from the ground. And of course, from time to time, it leaks. It causes large amounts of environmental damage. You have off-road vehicle damage. Now this is done by tourists. Because there's a lack of roads in Svalbard, you get, I don't know if you can see this on the screen, but these roads have been, this land has been completely destroyed by the large 4x4 vehicles. And with the industry of fishing, there's a reduction in fish stocks and overfishing. Now, once again, this is what I think is going to come up in your exam later this afternoon, okay? So, I think you're going to get a question on how to manage a cold environment, how to protect the cold environment. This is what I think is going to come up. So, you can talk about the use of technology. So I've just told you we have oil leaks in places like Alaska. So the solution to that is creating state-of-the-art oil pipes to transport oil many, many miles across the country or continent that is in. They've got this in Alaska. It's known as the Trans-Alaskan Pipeline. You've got action by governments supporting these particular areas. You have international agreements where countries are working together to reduce and minimise economic activity in a way that harmonises with the environment. And of course you've got your conservation groups, such as the WWF in Canada. You could also say as well, guys, things like fishing, giving fishermen fishing quotas, so they can only catch so many fish in a given time. So fish stocks in the Barents Sea to the south of Svalbard are not reduced too much. Right, coastlines, you know this. When it comes to deposition, there's 4 depositional features, okay? So you've got spit, bar and beach. Now, I don't think those are going to come up. What I think will come up in the exam this afternoon is sand dunes. And there might be a question on the formation of a sand dune. So this is when you've got maybe like a bit of debris on the beach, sand that gets stopped by it, intercepted by it, and it builds up over time. And then over a period of time, you get these large grasses known as marram grass, and that develops the sand dune. Also a soft engineering strategy, okay? So sand dunes might come up. Okay, so if you get a question on levees, remember levees are formed by 2 processes. Number 1 is flooding, the second is deposition. How do they form? In the river channel, you've got small bits of sediment being transported down the river in the flow of the river. When there's heavy precipitation, rainfall, that river level rises quickly. It floods the floodplain, the flat land around the actual channel. The sediment in the flow is lifted onto the floodplain in the flood waters. Now, when the flood waters return back to normal, that sediment is dropped, deposited on the side of the actual river. Now, that deposition of sediment builds up over time to form raised river banks, levees. Now, that process happens again and again and again. So over time, the levees increase in height. Equally, a floodplain, the land around the lower stages, is also formed by those 2 processes. The flooding of the river and the dropping of sediments. These are your hard engineering methods. So number 1, make the river wider, make it deeper. Secondly, increase the size of the river bank. The last way you could do this is, if you've got a river running through a city, that's bad news. Why? Because the city is impermeable. The land is impossible for water to get through because it's concrete, right? So therefore surface runoff is much quicker. So what we want to do is, when we've got a river running through a city, is we want to divert that river around the city centre and make it catch up the river later on, therefore decreasing the amount of water flowing through the actual city at any one point. So hard engineering, large scale, expensive, invasive, but very, very effective. You also have soft engineering. So 2 things here. You've got afforestation, which is the planting of trees. Why is that good? Because more trees, more interception. More interception, more infiltration. More infiltration, slower surface runoff, because it's been stopped. So the water level isn't going to be rising quickly. It's going to rise slowly. So afforestation, planting trees. The second one is planning and deciding what we're going to build and use the land for around the actual river itself. Now, normally, the more economic value assigned to a particular activity, so for example, industry or housing, that will be on higher ground further away from the actual river itself. So I know you're already tired, but this is the final bit that I'm running through. So give me 2 more minutes and then we're done. All right, so well done so far, all of you. Now, final checklist, number 1. Just like I said at the start of this video, in this paper there's 3 sections, section A, B and C. Section A, you answer everything. Section B, answer everything, but just be mindful that you answer questions on cold environments, not hot, because you will be given the option. And in section C, there will be questions on coasts, rivers and glaciation. You do questions on the first 2, coasts and rivers, not glaciation. Make sure, because this was a weakness of ours back in December time, you're all amazing at it now, but just be aware to make sure you reference the figure if a figure is included. So for example, figure 2 shows this, use the figure and your own understanding to explain, whatever it might be. So make sure the first thing you write down is figure 2 shows, and then talk about your own understanding. Number 3, develop and expand your answers when you can. So don't just write down one single point, try and develop it. So write something down, this leads to, write something down, this can cause, write something down. An effect of this is, write a definition down, but expand that definition. By doing that, you could potentially pick up an extra point to your original point. So develop and expand whenever you can. Be aware of your time. Now there's quite a few of you in the room who you like to be a perfectionist. So when you write your answer, it's all perfect and you want to keep it all neat and tidy, which absolutely, keep it neat, keep it tidy, the examiner's got to read it. But remember, you've got 90 minutes. Not 91 minutes, 95 minutes, you've got 90 minutes. That's it. And you've got to get all of those questions done. So, read the question, think about it, just write it. Just write it. Just get it on paper as quickly as you possibly can. There are a few of you, you know who you are, I'm not going to name you. Focus, concentrate on your handwriting. If they can't read it, the examiner, you're not going to get marks for it. So keep your writing try really be very mindful on what it is you're writing. Keep it neat, but at the same time, just be wary of your time, okay? You do need a calculator. There will be mathematical questions in the paper. What I would say though, year 11, is don't spend longer than is necessary on a maths related question, because it will be worth 1 or 2 marks, which is still important, but at the same time you don't want to be spending 5 minutes on a 1 mark question. Doesn't make sense, okay? So give it your best shot, take your calculator, but just get to those geography questions, because that's your strong point. So just be very careful not spending too long on those maths questions. Number 6, do not stop writing. Now, I don't care if you finish 5 minutes early, 10 minutes early, half hour early, 2 minutes early, I don't care. Don't put your pen down. As soon as you've finished, you've got 7 minutes on the clock, that's 7 minutes of opportunity. So go straight back to the start of that exam paper, go through every single question, but don't just stare at it, well, that's a waste of time. Read it, actually read it, word for word, and find something to write for each question, each answer, in addition to what you've already done. You only put that pen down when the person at the front of the room says, pens down. Keep writing. This paper, this Unit 1 paper, is the paper we're going to pick up the most marks. The next one is harder. So we want to make the most of the 90 minutes we've got in this particular paper, this particular exam. So don't put that pen down, keep writing. I'm talking to 2 or 3 of you in this class, you know who you are, I'm not going to name you. I can't believe I'm saying this, but put your name on the front of the paper. Paper, pen, first name, surname, candidate number. If you don't do that, you don't get any marks. What a waste. Write your name fully on the paper. Right, last one, number 8. If you're unsure, and there will be, 100%, every single one of you listening to this right now, you're going to have a question in that paper that you are unsure of. You'll read it, I think it's this, or it might be that. Oh, is it? Just write it. Just write whatever you think, write it down. Remember, that examiner who marks your paper, he can only mark you up, he cannot mark you down. So even if you write something that is inaccurate, it's wrong, so what? You can't get marked down for it, you can only get marked up for it. You might squeeze one mark. So do not, under any circumstance, leave any answer blank. Don't do it. Write something. Look at the words in the question. What do you know about one or two words in that question? Write about that. Keep that pen in your hand. Keep writing, even if you're not sure. Just write something. Be confident. Write it anyway. That's it. So, all of you, I wish I was there with you today to get you into that exam, but I'm not. I wish all of you the best. Good luck, all of you. I'm so proud of you lot. You're going to do amazing in this exam. You are. I said it from day one. That first lesson at the start of the GCSE course, I said that you're all going to achieve your target grades or exceed them. Today, you do that. Go into that exam calm, relaxed, and confident. Because trust me, you have got this. I'll see you all when I get back. Good luck.